Uh,
Now, without any further...
Yes, Kanan, you may start with the first session. Start, please.
Okay, sir. Thank you. Now, without any further ado, let's begin with our first session for today. In this session of today, we are going to discuss about sustainable building practices, and we have the privilege to have Dr. R.K. Gajjar ma'am as our expert for this session. Ma'am is working as a principal at LD Engineering College, Ahmedabad, also member of Research Council and Academic Council, Gujarat Technological University. Dr. R.K. Gajjar ma'am is member of Institute of Engineering India, Indian Society for Technical Education, Gujarat Institute for Civil Engineering and Architectures, Indian Society for Earthquake Science, Ahmedabad Management Association, and much more. Ma'am has also published 28 international journal papers, 15 national journal papers, total 66 publication papers, and much more winnings. If you have any questions during the session, please type them into the chat box in your control panel. I'll bring them up during the session. We will have time for questions at the end, so I request no one to switch on their mic or camera during the session. Now, without any further ado, I would like to give my warmest welcome to ma'am and turn over the time to ma'am. Thank you.
Thank you. I have shared my screen. Is it visible to all?
Yes, ma'am.
Niro, sir. Niro, sir.
Madam
ne presentation.
Ma'am, 1 minute. Yes, ma'am.
दिखाई से PPT ने, ma'am ने. Ma'am, yet it is not visible.
Ma'am, please share.
Okay. I'm sharing my desktop.
Yes, please.
Yes, ma'am. Yes, it is visible.
Okay, it is visible now?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
ये कॉरिडोर साथ में है.
Ma'am, start your presentation, ma'am.
Yeah. Just one second. Okay. Is it visible now? Hello.
Yes, ma'am.
Yes, ma'am. Yes, ma'am. It is visible.
Okay, fine. So, warm welcome to all the participants. And today I'm going to talk on the sustainable construction practices, primarily in the construction industry. We will be talking about the construction sector, some of the major concerns. What can be sustainable construction practices? What are they based on? What are the basic concepts? Some key features of sustainable construction, and in the end we will also be seeing some case studies. So to start with, what exactly do we mean by the sustainability issues? What are sustainability issues? Why is every citizen of this earth talking about sustainability suddenly? So if we look at what is immediately visible, the climate change, everyone is able to see the kind of changes that we are facing in and out in terms of temperature, in terms of the rains, in terms of even the cold that we are facing. So this is, even without knowing any aspects of sustainability, the change is perceived, it is visible. But if you look at the seriousness of how fast this change is coming, to give you a little bit of an idea, the temperature will rise by 4 degrees Celsius by 2100, 8 degrees by 2200. Now we are aware that even a little bit of rise of temperature is going to just imbalance the entire ecosystem, the entire living system of this earth. And if we see the rise of this kind this fast, we don't know where we are heading. Very close to our home, the eastern Himalayan forests are turning brown. This is happening across the globe, in all the rainforests also, Amazon also, South Africa also, but this is right at our doorstep. The emission levels of CO2 per capita for India is 2.44 tons. The scientists forecast that the climate changes will cause more extended droughts. Now, on one hand, we are seeing so much of rain and so much of chaos due to the urban flooding that is happening across the world. And how can we manage the droughts? These are the issues which seem really very far away from us. Each person in their surroundings, in their homes, in their communities feels that, oh, this is climate change brought on by some developed country. This is temperature rise brought on by some other industry, some other community, some other peoples, but not us. And therefore, this is the time where we have to sit down and look at ourselves in the mirror. Is it so far away from us? Has someone else brought this upon us? Or are we collectively responsible for what is coming on to us and what we are creating for the future generations? Unknowingly, of course. In fact, this is a generation which has proliferately used the resources. Our generation appeared to be very lucky, very forward, very developed, because all of a sudden we had at our fingertips so much of technology, so much of resources. And therefore we have been using these resources proliferately. We have taken a lot of advantage of these resources. And this is a point of time when the quality of human life, the kind of structures, the kind of infrastructure that is needed for any industry. I'm not talking as of now of only civil engineering. Any industry needs the kind of infrastructure which was unforeseen, unavailable till very recently. But this is the time which also brings us face to face about the big question. Are we on the right track? Are we doing exactly what we should have done? We need to stop and look back at what our forefathers had done. Maybe at some point of time we felt that they did not know much. We have the knowledge at our fingertips. The internet is here. The innovation, the opportunities, the policies, everything is at our fingertips, and therefore we feel that we can move ahead very fast, and we are much farther ahead than our forefathers. True. But our forefathers were slow, and to a certain extent they had the benefit and they had the luxury of being close to the nature, being able to stop at some point of time, slow down their pace and reconsider what they were doing. Unfortunately, we have hurtled ourselves very fast into the future at a pace at which we had no idea where we were heading, till the time that suddenly we are faced with these grave issues. So let's talk primarily about the construction sector itself. If we look at what is the quantity of non-renewable resources that we are using as of now, how much of the water, how much of the energy, the fossil energy that has been used. What is it that we are doing to the biological diversity? Every day we are looking at species that are becoming extinct or near extinct, and we are all confused. At some point of time, when there is not much control that we have, we may take the stand that, okay, fine, I was not responsible, and I do empathize, I do sympathize about the biological diversity that is vanishing, but I am not responsible. So this is the stand, this is the attitude that we need to look at very closely, very minutely, with all the sensitivity that our forefathers taught us to do. Because every biological aspect leads back to our life, leads back to the quality of life, leads back to the technology that we are developing, the technology that our generations are going to use. If you look at the forest areas, the urbanization, the urban migration, we have come up with lots of fancy nomenclatures. We are talking about the rurbanization, we are talking about decentralization and bringing up our rural areas so that we have the urban kind of lifestyle in the farthest of the corners. So in fact, this also brings me to the point about this, Dr. Khare mentioned about the tribal belt of Dahod. So to my mind comes this question: are we happy the way we are, or do we really want to hurtle ourselves into a fast and forward future, which, and we have been given these pictures of urban infrastructure, and every person has felt, oh my God, I hope I have that kind of a lifestyle. I wish I were able to work in this kind of a building, or an office infrastructure, or the roads and the bridges and the metros that we are able to see. And there is a dream that has been put into our minds. So we need to take a very holistic view right now about what we want and where we want to go. We are talking about agricultural lands, we are talking about air, water, soil. We are talking about the natural green areas which are fast disappearing, even in close to our rural and vegetative and tribal grounds that we so much enjoy. They were enriching our lives without us knowing about it. And naturally, the biggest worry is the global warming. If I talk about a few numbers, let's just stop for a while and look at what as a construction industry we are doing. Any industry. Right now, if we talk about IoT, we talk about artificial intelligence, we talk about data science. Every industry needs infrastructure. That infrastructure is provided by the construction sector. So the construction industry is massively impacting nearly all of the industries across the globe. It accounts for 6% of the global GDP. The building industry, on the other hand, produces 1/3 of all the waste on this globe. And where does it all go? Somewhere in the landfills, somewhere it is just being piled up. Many engineering industries are coming up, finding solutions of how this waste can be reused, properly used. In fact, we are also finding issues about disposing this waste. And if you look at whatever we are producing, talk about cement, talk about steel, talk about the bricks, 11% of the world's greenhouse gas emission comes from the construction industry. And so we as an industry, we as a part and parcel of this whole industry, as civil engineers, face this huge challenge of reducing our environmental footprint, of reducing the carbon footprint. As I said earlier when I started, that we have led the entire industrial revolution in terms of giving some wonderful infrastructure. And thanks to the construction industry, the other industries have been able to proliferate. But at the end, the other industries will not stand by where we face the challenges. They will say, you were the experts, you were the technocrats, you knew that you were using the irrefutable resources. You were depleting the resources. So we as an industry have to stop at this point. Look at our environmental footprint. Reconsider what we are doing. Take a stand. And mind you, as I said, we cannot just say that global warming is someone else's responsibility. Just as the other industry, the computer industry or the internet industry is going to say, we were not responsible. You created this infrastructure. You knew what you were doing. We didn't know how cement is being produced. And so we hold a very, very responsible position at this point of time in creating a sustainable future for our future generations. So we need to talk about resource consumption. We need to talk about water management. We need to talk about waste, minimal waste, as well as how to reuse the waste. And therefore, we cannot just keep going on and on and on in creating new infrastructure without bringing all in one platform and make them understand. You want this? This is what is being depleted. This is what needs some management. And therefore, whenever this question of management comes, along with it comes the question of cost. Along with it comes the question of responsibility of sustainability. We have to bring it to the awareness level of all the other industries that there is a cost involved, and we need to look at the cost benefit ratios. This is no more a world where we can just say that we are economical and we save money. We are beyond that point already, as I showed in the earlier slides about the global climate change, the depletion of forests, the depletion of water. So let's look at the impact of the built environment. You can see over here 30% of energy, 40% of resources, 25% of water goes into the built environment. And who is responsible? Who has to stop and think and put up questions? Mind you, this is not the time where you have to know all the answers. There are many aspects for which we are still not aware. Pandya sir recently talked about the mining aspect. We do not know much about the mining aspect, but that does not mean that we are supposed to give the answers to that. What it means is we need to ask questions. If this is the energy that is being used, if these are the resources, the fossil fuels that we are using, if this is the water that is being consumed, then all of us collectively have to have answers of whether we want to continue, whether we want to reduce, reuse, or find alternates. There will be completely new branches of engineering about biotechnology, about AI that we have to get familiar with. We cannot restrict ourselves as civil engineers only to the built environment. We have to understand the entire ecology. Otherwise, as I said earlier also, the governments, the policies, the climate change awareness people are going to come down banging on our doors and ask questions. If we do not raise the questions and ask others, bring a common platform about, start looking at these questions. These are the issues which we are facing. Somebody find solutions. If we are not bringing those questions now, if we are not aware of the technology, for example, where is AI going to lead us? You need to have hundreds of thousands of billions of data which should be analyzed using AI and come up with solutions that, okay, fine, this is where some alternates are needed. Then will come up another branch of engineering, which will say, yes, I have the alternates. You are going to talk during these 5 days about many alternates, about replacements, about good additives. But we also need to start looking at alternate technologies, about how AI can impact the built environment, how to use it to your advantage. Throw up as many questions without the fear of having to answer them. You are not going to be responsible to answer all of them, but you will be held responsible if we do not raise the questions at this point of time. So there's this aspect of the greenhouse gas emissions. Till now, to be very honest, in fact, right now too, how many of our students in our classes, in our civil engineering classes, are being asked this question: who is responsible for the greenhouse gas emissions? I'll tell you, ask these questions and you will be coming up with surprising answers. They will come up with answers of all the air conditioners. They will come up with all the answers of the HVAC systems, of the jet propulsion fuel, about everything that the developed world is doing. Are they aware that the manufacture of cement, the manufacture of steel are the biggest greenhouse gas emissions? Now, this is what we need to bring into our classes, along with our curriculum, into our curriculum, and make them aware that all the fancy buildings, all the fancy infrastructure, all the fancy technology comes hand in hand with the responsibility of sustainability. Another question which we need to bring to our classrooms is, what happens when a building outruns its designated life? What happens to the material? Do you just tear it down? Now, these are the questions which very early on, we as civil engineers have to start putting in the minds of common civilians, especially in the minds of our undergraduate and postgraduate students, so that when they use the technology, they are at the back of their mind responsible. They will know that somewhere down the line, I am putting into the hands of an unaware citizen, which is going to come back to me. I will be asked at some point of time, I, in the sense, my community of civil engineers, will be asked, what did you do? Were you aware at that point of time that you do not need this kind of technology, or you have misused this technology? So if they are aware very early on, they will come up, and I have a huge respect for this current generation. They are very technology savvy, they are much smarter than our generation, and they will come up very fast with alternatives. But we as a community have to bring it to the level of their awareness, that there is waste, there is recycling, there is some optimal use, some alternates that we have to continuously reinvent. So the major concerns, the conventional approach underlying all the development activities, believe me, are completely unsustainable as of now. What we are doing as the routine practice, as the done thing, the norm that was followed since eons, since the time that man took up the first construction project, the small hut that they created, are no more sustainable as of now. Within our community, we also need to realize that many of our practices are unscientific. There was no base. There was a need at some point of time and therefore it was adopted unquestioningly. And last but not the least, materialistic. The humongous amount of material that we are producing, using, and leaving it to waste. We do not have answers. To be very frank, there have been crazy experiments also about throwing them into the sea, into the space, but we know now that that is not going to help us. Everything is going to come back full circle, and we will be at the center of that question. Our entire generation, our future generations stand at a risk. We have to accept that unsustainable, unscientific methods have to stop. How will we adapt? How will we bring in completely new methods? Who will start that are the questions. Very difficult questions, very tough questions, but if we do not ask them, we will not find the way forward. We will not look at alternatives. We have to reinvent. We have to look at completely new sustainable materials, new sustainable technology, and the whole argument that where is the money? So someone is going to ask this question to you, where is the fund? You will have to be prepared with alternatives. And there is a lot that we can learn about the alternatives if we open the third eye. We start asking ourselves these questions, because we are not going to survive the climate change that is predicted, the material depletion. In fact, right now, everybody knows what is happening to sand mining. What is going to happen to our concrete? How many of you from this whole group of participants is already looking at alternates? Now, if you are looking at the alternates, the one fact has already been accepted, that our natural resources, even the government policies, if the policy says that no more of this is illegal, you cannot do it. So what happens? Do we stop construction? So we look at alternates. Now, when we look at alternates, we need to understand that, okay, at some point of time, that alternate will also be questioned. So better start looking at the sustainability aspect of that alternate also. If we talk about the waste production, once again, a big question to our entire community. How many of you are already talking about reusing waste concrete, about reusing the construction material, of producing a new material out of the wastes? So many scientific theories, so many experiments are already underway. I'm sure this is going to lead us to some really very good solutions. But again and again and again, I am going to come back to that question. That solution has to pass through the test of sustainability. That has to pass through the test of the carbon footprint, about the toxicity that it is going to create, about the use of the natural resources that it is going to take up. And also it is going to ask us to bring us to a point whereby we need to think about the habitats, the natural habitats that we are destroying. Now, here I'll also stop for a moment and ask this question to all of us. If a particular species disappears today from the face of the earth, are we directly impacted? First, as humans. Second, as engineers. Third, as civil engineers. So this looks like a very crazy, very unsound question. I'll repeat again. If a species disappears today, is it directly going to impact us as humans, as engineers, and particularly as civil engineers? In a very hasty way, the answer is no. Because that species is not right at your doorstep. That species is not being used by you directly. The species is not at all connected in any way to your infrastructure, to your civil engineering, to your technology. But if we look deep, everything is connected. Everything that it's a cycle that is started by the disappearance. There's a complete ecological cycle which leads to water depletion, which leads to natural resource depletion, which leads to the devastation of entire forests from which you are using the fossil fuel right now to create your cement, to create your steel. And therefore, what seems so far away is no more that far. It is here and now at our doorsteps. The important thing which we as engineers missed, which the climate change naysayers kept on saying, was that each individual decision of a citizen, of a community, we as a community of engineers, is going to impact the other aspects also. So in short, what we are saying is my individual life and my individual decision is too small, too far away to be able to change the problems of the globe. So we need to understand now that that was the wrong attitude. We need to understand that my individual decisions, my individual use of even the smallest of nano iota of the resources, my individual decision of an unsustainable use of technology or material does impact the entire globe. We are intertwined. We cannot say that it is the future or it is the past or the calamity was created by someone else. It is too far and I will somehow be able to survive and move out. Because this is the generation that will be held responsible for many more generations. So let us look at the actions that we can initiate. As I said, and I have tried to build context, that there has to be a complete paradigm shift. We have to think new, a completely new future, and therefore there is always this fear of failure. Too long we have moved ahead fast because there was success. There was a small step of success at every point. You do an experiment, you test it, you create a model, you have all the best of the best softwares which say that yes, okay, this works. But at that point of time, we were not sure how it is going to impact our worlds. So now, when you try completely fresh, look at the pandemic, the COVID. The entire scientific community, the entire medical community, the entire pharmaceutical community, what are they doing? They are reinventing. This is something which no one had ever known. This is exactly the situation that we need to face within our realm of the construction of the civil engineering domains. We need to start looking at something that will be totally new. Therefore, there is this whole risk of failure. There is this whole risk of a community mindset being created to be able to move forward from our experiments. It is okay to fail. It is okay most of the time not to succeed. That is the paradigm shift that I am pointing to. because ultimately sustainability is going to be the #1 question. If we talk about the construction industry, we need to adopt practices which were unheard of so far. We will look at some good examples. In fact, at this point of time, I also have to thank my colleagues, my students who have helped me create this entire theme for today. A lot of research has gone into it, and they have helped me put this together. And as I said, all of us are learning. This is just the learning, the beginning of the learning. What do we need to do as a construction sector? So we need to look at the primary question that comes from a business model, that comes from the policymakers, is it economically viable? So I come back again to that whole question about knowledge, which is useful only if it has a business model. The business model is useful only if it is scalable. But the moment you scale it up, you are lost if you have forgotten the aspect of sustainability. So everything is intertwined, complex. If we talk about economical viable solutions, we might face that question that, okay, fine, drop it. It is not economically viable. So here comes a big question. Is it environmentally benign? If not, does the cost take the upper hand or the environmental aspect take the upper hand? We have to stand up rather, as a community, ask this question to our clients, to the governments, to the climate change people, that this is not environmentally benign. However, this is the cost which we have to bear. And at the end of the day, if it is so exorbitant a cost that it will socially be not accepted, we have to start reinventing. We have to start looking at new solutions, at new aspects, at new technology. And if we are true to our heart, if we are sensitive to this primary question, then there are solutions. We will find good solutions. They will come up, they will appear in front of you if you keep on and on and on, trying and not giving up. Paradigm shift, the old paradigm. In fact, this is the current paradigm. We have constrained ourselves in terms of how early will you deliver? What is the optimal cost? And at the same time, we do talk of quality. So we have just taken into account these three factors. Everybody is happy, the client, the engineer, the investor, that okay, fine, everything is good. You have taken care of a good cost benefit ratio, and the quality that I wanted is reasonably available to me. What is the paradigm shift that has to be brought onto the mindset of every citizen, of every user of this technology? It's just one small part of the new paradigm. The new paradigm talks about human satisfaction. It talks about minimal negative environmental impact. It talks about the sustainability, reducing the carbon footprint. Now, these are the paradigms, as I said, did not appear anywhere in our textbooks. As I also pointed out, each of us as teachers have to spare time at the cost of not finishing our syllabi to make every student aware of these issues. They need to know that whatever I do, I am bringing this into the life of the common citizen. I am bringing this into the whole realm of administration. And naturally, when you bring this into the realm of administration, in the realm of usage, in the realm of the economy, there will be others, because everyone has to stop. You can't just be held responsible for a certain amount of sustainability that you can handle. The rest has to be shared, but you have to create that kind of the mindset, the right kind of questions. We might not have the answers, but we have to stop. So the new paradigm is much more humongous. Believe me, you need to bring a common platform whereby the responsibility is shared. It will be shared. Responsibility is, all of us know, never shared so easily. Everybody is going to pass on the baton to the next person, to the next creed of engineers, that okay, fine, the environmentalists, you go and do your research and give me a solution. The IT people will say, I have done my lot. So this is the time when we need to intermingle. We need to learn about other domains so that you ask the right kind of technological questions that help me. I need this, and can you create this kind of a structure, this kind of a system for me? You need the mechanical engineers, you need the electrical engineers, you need the electronics engineers, the instrumentation engineers. But we as a creed have been very happy learning more and more and more about civil engineering, and somewhere down the line we missed a little bit on knowing about more technologies because we thought that we do not need them. But in this new paradigm, in this larger question,
Hello, ma'am.
Kanan देख रही है राइट बार चली देखो मैं डीपीज कर रहा हूं कल समझ अलेक्स
Sorry for the inconvenience. We think there is some kind of network issue. We will shortly restart. Hello, ma'am. Hello, ma'am. Can you hear me?
That is the only thing that is not happening. Okay. Someone did that for me. Okay, fine. So now. Yeah. So what I. हाँ पण મારે હવે મારી સ્ક્રીન શેર કરવી છે. Okay, can you see the slides now? Can you see the slides now?
Yes, ma'am. Yes, I can see the slides, ma'am.
Okay. एक minute. Problem slide show માં જઈ રહી છું પણ I think that is causing the problem. Okay, can you see the slides now? Hello?
No, ma'am.
You can't see the slides?
Yes. Now we can see.
Oh. Now you can see? Okay, can you see? Is it visible now?
Actually, it is taking 3 seconds buffer time to.
Yeah. I know.
Now it is visible.
But is it visible?
Yes, ma'am. Yes.
Okay, fine. So we're talking about. I think you heard me till the old paradigm and the new paradigm. Is that okay? Hello. Okay, fine. So I'll continue from here.
Yes, ma'am.
Okay, fine. Yeah. So let's these glitches, online glitches are there. Let's continue with the aspect of sustainability versus the sustainable development. Now, when we talk about sustainability, it refers to the viability of natural resources, the ecosystem, and maintenance of the living standards of humans. And when we talk about sustainable development, we talk about an entire process wherein each of us responsibly takes action, takes decisions, and we are able to bring in some kind of technology which does not just say that, okay, fine, there is a problem, but there are no solutions. So coming down, boiling everything down to the construction practices, sustainable construction practices are those that will fit well with the goals of sustainable development goals. There are sustainable development goals which have been declared globally, which have been accepted by all industry, and we as one community cannot just stay away and say that this is all that I can do. We have to fit into the sustainable development goals, and that is where we have to move forward to. That is the only way to be able to contribute and to reduce risk. Optimizing cost, of course, will always primarily be asked by every individual. They will also talk about improving the processes for efficiency, but we will have to create processes. We will have to create products. We will have to create services which are at the end of the day environmentally benign. Only if they are environmentally benign, and in addition to that, they are able to talk about optimizing cost or improving efficiency. That is an added advantage. But at this point, we have to think we have already crossed the line about the cost and the efficiency aspects. We have to now talk about our products, our services, and our processes which fit into the sustainable development goals. So there are three major aspects which the sustainable goals cover: the environmental impact, the economical impact, and the social impact. Let's start with the easiest one, which everybody asks us about, is the economical impact. Linear to circular economy of renewable energy. We talk about renewable energy. A lot has been done in this whole domain of renewable energy. We have to start utilizing it. Similarly, as we already know, in these 5 days itself, we are going to talk about new material, we are going to talk about reusing, about recycling. So we have to talk seriously about it and put it into practice. We can't just say that we experimented and this worked and this much percentage of the result is available, but we do not know anything further. So what will happen in that situation is people will fall back to the old systems in the absence of new material, new processes, which raise more doubts rather than taking us forward to the sustainable solutions. We talk about water. Water harvesting and preservation is going to be the #1 goal in a very near future. We also have to talk about transferable technologies. We cannot say that instrumentation and control has the sensors, but they'll be the people who will use those sensors to our advantage. We have to start learning. We have to know the use of these sensors. Where do we put them? How do we use them? Where will they come in handy to create the artificial intelligence, the kind of data that is needed, the kind of cloud data that is needed? We have to talk about transferable technologies whereby our transportation, our construction is understood by the other domains, and we are able to understand the other domains to bring them into our technologies. The adaptability of structures is another very important aspect. Today you have a building which was created with a certain focus, with a certain use that was predefined by the client. Very quickly you might not be wanting that building to be able to stand there for the use that it was designed for. What do? Do you bring it down completely, tear it down? Initially, we had that luxury. A lot has been done. Buildings have been torn down. New buildings have come up with their new usages, with their new infrastructure facilities. No more of that. We have to let it live till its design lifespan so that we have minimal waste. We have more of sustainability on our hands. So reusing, adapting ourselves to the structures which are available is also going to be a science and engineering that we have to teach our students. Financing models. So far, we have not touched upon the financing models so much within our curricula, within our construction technology itself. It was the banker's domain, it was the financier's domain, it was the investor's domain, but we have to bring it into our domains also. As we move up the ladder of the impact, we will talk about the environmental impact. What is the environmental impact of the built environment on the entire domain of the globe? So we need to bring in designs and management. All of you are now familiar with BIM. All of you are familiar with the new kind of management systems that not just optimize the materials, the cost, they also optimize the processes. So it's end to end. You know exactly when this kind of material is needed, at what place, how much of it, so that you save on the transportation, you save on the kind of time management and wastage. So these are the new technologies that you need to understand. Performance of materials and their life cycles. We talk about fibers, we talk about rice husk, we talk about new material which we are presuming is going to be the need of the hour, and therefore a lot has been done. We have covered a lot of domain. We have arrived, but we need to start putting it to use and constantly keeping an eye on its reusability, on the sustainability aspects. We need to look at renewable energy sources. Whatever we do, we cannot now say that HVAC is the domain of the mechanical engineers or the electrical engineers. We have to sit down with them. We have to ask questions about where are we going in terms of the energy, in terms of the source of energy that a particular infrastructure is going to use. And so we come to this whole attendant technologies in building, operations, maintenance. Primarily, the single question that needs to be answered at the end of the day, what is the greenhouse gas emission that you have reduced? And based on this comes the social impact. Because if you make your systems extremely costly, if you make systems which are unviable, if you suddenly say that no, you cannot go beyond 10 stories, or you cannot just expand, or you cannot readapt your structures, you are out as a whole community. Who wants people who do not have solutions? So the social impact has to be very high on your cards. High ethical standards for the quality, for the integrity, for the environment are expected. We have to stand up to that expectation. Socially viable living and working environments. We cannot now have the luxury of saying that every person can stay somewhere else and go to work about travel 2 hours in their cars. So everything is impacted. What about your transportation systems? What about your habitats? What about your work offices? So redesigning entire communities also falls into our domains. Occupational health, labor forces, use of built environment, and the ultimate wealth of the community. So key features: design integration, material selection, resource conservation, construction waste management, very, very important, and lean manufacturing techniques. These were unheard of in our dictionaries so far. We never talked about lean manufacturing. We need to talk about it more and more. We need to look into the processes that are being used. If we talk about the design integration, let's look at this entire new domain with the client at the center. So the client at the center, till now we had the structural engineer, the contractor, and we had the architect. So here is this whole domain of the new services, the new creed of engineers that come into the entire built environment. We need landscape architecture, we need the MEP consultants, the project management consultants, and also the green building professionals. Start looking at the green building criteria, start looking at how that can be incorporated right from your design to manufacture, to use, to reuse, to readapt your buildings. Think long term. Think of how this is going to be impacted. You alone, either as a structural engineer or a construction engineer or an architect, will not be able to come up to the right solutions. And therefore, this integration of this whole domain of project management consultants, of green building professionals, of MEP consultants, of your HVAC systems is very much the need of the hour. And of course, the client is going to ask crazy questions. They need to know. We cannot say that this is not your domain. Some other aspects that we need to very seriously look into is the resource conservation in terms of the land, in terms of the water, in terms of the energy and the material. So if you talk about land conservation, adaptive reuse of existing buildings, this is a just excuse me for a second, just excuse me. Hello? Hello? Yes? I'm sorry, there was a call from the minister's office. So we need to look at existing buildings and their reuse. Small amount of changes have have to be part of our design process. We need to allow them rather than just bringing down entire buildings and new construction. Location of construction project sites close to existing infrastructure. I talked about the transportation, the office use, and the habitats. And we need to talk about development of non-arable lands for construction. We have to create create the spaces that are adapting to the land rather than adapting the land to our spaces. Plumbing fixtures, the fixtures have come up in every form and design, in every fancy economically unviable costs. But ultimately, at the end of the day, are we putting in the hands of the citizen a very, very efficient water usage system is what we need to talk about. We need to reinvent. We need to talk about collection of rainwater. We cannot allow it to just run away. Employ recirculating systems and design low demand landscaping. So that is where when we talked about the other engineers, the other experts that we need in our domains, with whom we have not yet worked, we need to start working with them. Energy conservation, low energy intensive transportation, energy efficient technological processes, choice of materials also makes a huge difference, and energy efficient deconstruction. We'll talk a little bit about the deconstruction also. We need to create buildings that can be, with minimal of deconstruction, put to reuse. Similarly, materials, waste reutilization, a lot of work is already being done in that. Durable materials. We need to look at material which have a very long lifespan so that the wastage that we create, the ecological back-breaking material that we leave behind is reduced. We need to start looking again at natural and local materials and primarily at non-toxic materials. Construction waste management, the biggest issue that we are facing in today's world. So we need to management of waste. We need to look at if this is the waste, just as much as the material that we are using, we teach our students to learn how much material goes into this. We also need to make them learn that if deconstructed, if destroyed, this is the amount of waste. You need to understand and calculate that this is the amount of waste on our hands, and therefore this is where we will dispose it of or reuse it. This is a science which we have to start teaching very early on. Along with that, as I said, what is do we have a creed of engineers that have enough of haulers, enough of technology that will transport the nearest site? We understand how this debris can be diverted, reused, and reused to advantage. Can we say that the waste concrete that is being used will be able to stand for? Excuse me. Can you hear me? Hello?
Yes, ma'am, you're audible.
Yes. Yeah. Okay. Okay, fine. Now, once I am a little bit confused whether I'm still. Okay, fine. So similarly, we need to talk about material selection of material which is close and low cost only this stone or only mud. We experimenting with local material and rose it. That is the only way of reducing carbon emission. Only way able to come up with sources. So what is the material that must say? Design durability, maintenance, and select material aid adapt. Renewable materials.
Hello, good morning, madam. Are you
Hello.
Are you here? Good morning, madam.
Good morning.
Yes, is the slide visible?
No, it is not
No,
visible.
ma'am. You are not visible.
Can you see the slide? Hello?
Yes.
Yes, ma'am. It's
Hello?
take a time, ma'am. 1 or 2 minutes, ma'am.
Okay. What I'll do is just give me a moment. I'll shift over to a network because I think the network itself is creating some problem. Just give me 1 second.
Sure, ma'am. Sure.
You are not audible, sir.
Wait a minute, sir.
Your video is also not visible.
Just wait a minute, sir. Ma'am,
Okay.
Can
you hear me now?
Not yet, ma'am.
Not seeing. Can you see my slide?
No, ma'am.
No, ma'am.
Hello?
Hello.
No, ma'am. No, ma'am.
No visibility of PPT, ma'am.
Ma'am,
एक बार
slide is not visible.
एक बार आपने
Hello?
वो ऑप्शन निकाल
Can you see my
शेयरिंग
slide?
का नो मैम हेलो मैम एक बार आप स्लाइड नहीं मैम
You can't see my slide?
No, ma'am. Slide says not
No, ma'am.
visualized.
Okay, let me check. Now visible? Visible now?
No, ma'am.
No, ma'am. No, ma'am.
You know what? I'm getting a cross.
visibility.
देखा है?
ना मैम नहीं देखा थी.
See, what I'm doing is I'm sharing.
It's maybe it take a 1 or 2 minutes Okay, it's the term. Yes, ma'am. It's coming.
Yes,
I'm
ma'am.
sharing you
Visible.
right.
Yes.
Visible,
Ma'am, visible now.
because the sharing was,
Visible.
yeah, I was not allowed sharing.
Yes, yes.
Okay, now visible?
Yes, yes, yes.
Yes, ma'am.
Visible.
Okay.
No,
So,
no, yet, ma'am. Yes, yes,
okay,
now it is visible.
okay. Okay, so
It is a
let's
net
come to
issue,
the
that's why
discussion of concrete. Let's finish this quickly before another jerk in the transmission comes. Okay. Most widely used material, about 2.5 tons of concrete is produced each year for every human being. Some facts and figures which tell us why we need to be so very conscious. The cement manufacturing generates 5% of the global greenhouse gases, and it constitutes more than 2/3 of the total embodied energy. The annual global cement produces 2.8 million tons, and per capita consumption in India itself is 190 kg per year. So if we look at these facts and figures, we need to understand what do we need to do with our concrete. How judiciously we need to start thinking in the amount of concrete that we put in the infrastructure. The kind of greenhouse gas emissions, 1 ton of cement consumed in concrete absorbs 0.4 tons of CO2 while hardening. So the net amount of CO2 released in 1 ton of cement is 0.5 tons of CO2, greenhouse gases. By 2020, economical feasible stock. Can you hear me? I was muted.
Yes, ma'am.
Yeah,
Yes,
okay.
ma'am, you are audible.
About our aggregates, we've already talked about the river sand, about the sand mining, and the kind of issues which we are facing. So we need to relook completely at our aggregates and at our cement. So at our completely the concrete industry itself. How much is viable? How much is absolutely needed? So, as I said, a lot has already been done. We are talking about fly ash, we are talking GGBS, we are talking about rice husk, ultra fine FA and ultra fine GGBS. We are able to produce more durable concrete, ultra high strength. We are already going to do talk a lot in the coming days also. So this is already in. We are talking about lightweight aggregates, locally available aggregates, use of higher sizes of aggregate, optimum cement content, carbon sequestration of concrete. So this has been done very well. It is being put to use in a lot in the developed countries. They are already talking sustainability. They are talking sustainable goals. But we as a community in this part of the world have to sit up and transfer our technologies so that this becomes the new norm. This is the new normal that we have to adopt. Talking about the durability aspects also, the holistic approach for designing of durable structures would be design as per the environmental exposure, use the appropriate material, use the proper construction methods, plan it, use minimal time, more efficiency, and finally you also need to have the quality control. So these are the aspects we need to talk about day in and day out, rather than just creating infrastructure, about designing, about the material use, about the cost effectiveness. So we are well beyond the time, cost and quality aspects, and we have to bring into our domains the strength, durability and sustainability aspects. One another factor that we need to stop and look at is just beyond the new construction or deconstruction, the retrofitting. Whatever we have as of now has to be put to its optimum use, and therefore the retrofitting becomes a very important aspect of sustainability. We cannot just say that okay, the old building stock vanish and we create a new building stock which is more sustainable, which is better suited to the future needs. So we need to look at avoiding unnecessary construction, but at the same time retrofitting using the sustainable development approaches. So you need to look at the ongoing philosophy, you need to look at the service life, how much is needed, what is the maintenance, what is the repair, and go ahead and retrofit very responsibly our built environment. Naturally, it will extend the economic life of the building. It will reduce the kind of landfill that we are really worried about from the waste materials. And inherently, it gives you a more sustainable future, less consumption of resources, energy, transportation, and of course, the pollution and the greenhouse gases. So types of retrofitting, also we need to look at green retrofit, general retrofit, and seismic retrofit. We need to look at all these aspects from the green retrofitting point of view, so that our general retrofitting and the seismic retrofitting is also incorporated, but at the same time it is at the end of the day green. What do we mean by green retrofit? So when we say that any kind of upgrade of an existing building is wholly or partially occupied to improve energy and environmental performance. Till now we have talked about retrofitting buildings which were depleted of their strengths. But can we start talking of retrofitting so that its environmental performance is improved, so that it uses more of natural light, more of air, less of noise? These are the new engineering systems that we have to start looking at, start developing, and start talking about. So green buildings retrofitting will need a lot of changing in the lighting, a lot of maintenance and upgradation of the heating, ventilation, and the air conditioning systems. It needs a complete relook at the water systems, the waterless urinals, recycling of grey water, capturing of rainwater, and of course the BIM that I have been mentioning about the building automation system, manage all operations, all systems, so that there is minimal footprint left at the end of the day with good cost, maintenance, and sustainability. So some of the examples: solar air conditioning, lighting controls, daylight sensors. You have the technology. So start using that technology to the best of its use and start creating green buildings. They are costly as of now, but believe me, very soon we will be facing a future whereby you will be asked, is your building certified as per the green building norms? And then everything will fall in place, all technology, all the cost will fall in place, wherein the new norm is going to be, okay, you need to have the green building parameters put in place. You might have to completely retrofit your existing buildings also, just like our transportation, our vehicles that are going through that entire change to reduce the pollution, to improve the air quality on the roads. Similar things are going to happen to our buildings. A few case studies. Let's look at this Institute of Rural Research and Development in Gurgaon. So from the very beginning, starting with the material selection itself, if you look at the emission of 640 tons of CO2, it was avoided by using a construction practice into this building. What did they do? Excavated earth from the basement is used for manufacturing compressed earth blocks. And this is a real building, this is existing, and therefore we can see how it is being reused, how it is being put in place already as a green building. Locally available stones have been used for the cladding, finishing, flooring, and as a substitute for the metallic and ceramic cladding systems. Water conservation. So look at this beautiful amphitheater that has been created. This amphitheater acts as a filter bed for the rainwater storage. So the scarcity of water in that region has been addressed by integrating a large rainwater harvesting system and the storage system in the landscape design itself. So here comes your water conservation, the green building enthusiast. Here comes your landscape architecture. Here comes the compressed earth blocks that are being put to use. So the whole domain, the whole cross section of engineering parameters which we talked about within the domain of civil engineering is expanding multiple scale. Rainwater harvesting. So rainwater has been collected for 100 working days and treated fresh water demand is being met by that. So this is a classic example of where we need to go to relook at each and every building that we are designing and constructing. Another example, the nomadic museum. Now this was a museum which had to be transported. It had to be designed so that it could be put in place wherever it would go. So it was to be designed as a temporary and at the same time transportable exhibit space. So it was intended to be there in a particular place for 6 months and then it would be transported to California, to Tokyo, to Mexico. So here is this whole new terminology, adaptability and deconstructability. You need to deconstruct it, not destroy it. You need to reconstruct it at its new place. So these are the new demands and new infrastructure. And look at it, it's meant to be a museum for art. So it itself has to look beautiful to attract people into the museum. So what are the features? Shipping containers were used as vertical supporters, as these were easily available at the port sites wherever it would go. The containers were made up of heavy gauge corrugated sheets that act like shear walls, providing inherent rigidity. Circular columns and roof truss members made of cardboard. The bottom row of containers were welded to the steel beams because you needed certain structural stability. The sleepers would then be used also again for the transportation and deconstruction. Third case study, Konark Railway, South Goa and residential buildings at RCF Mumbai. Glass fiber reinforced gypsum panel building systems were used. So rapid wall paneling using GFRG, calcined gypsum plaster reinforced with glass fibers, used as infills for load bearing as well as frame structures, faster construction, makes use of industrial waste gypsum, does not need any plastering, uses less cement, less sand, less steel and water than conventional buildings. The lightness of the structures also makes it safe for the earthquake forces, and the panels can be used as walls, not as floors, roofs and staircases. So these are some very quick case studies to elaborate on all the aspects that I talked about regarding starting with the climate change, to the construction methods, to the sustainability issues, to the new paradigm of sustainable construction. So we need to look at the construction sector because it is one of the most powerful sectors to make a meaningful contribution towards sustainable objectives. We need to look at practices which are important for the well-being of our planet. As I said, we are not working as individuals just so that our life is not impacted. Each individual decision that we make impacts the entire society. Believe it or not, the entire global community stands together in the decisions of the individuals. And we need to look at positive environmental impact of the sustainable construction so that we ensure effective management and design, enhanced performance of materials, and optimized utilization of renewable energy sources integrated with new technologies in the construction. we have to make our choices, and we are very well equipped, at least today, in the knowledge, in the sensitivity, in the decisions that we take for the human community as a whole. Thank you. So if there are any questions, I would be happy to take the questions.
Thank you very much, ma'am. Hello, thank you very much, ma'am. I request to all the participants, if you have any questions, please write in the chat box. Hello. If any questions from the participant side, I kindly request to write in the chat box so that we can ask to respected madam. Hello. Madam.
Yes,
really, it is appreciable for us that you have accept our invitation first, and on the instantly you said yes. Really, ma'am, it is privilege for us. I really thankful to you, ma'am, and it's such a nice series of expert lecture that keynote speak that you have given us to enlighten our knowledge, ma'am.
Thank you so much, ma'am, for this remarkable and enlightening session. It was a pleasure to hear you. All the participants appreciated your renowned lecture in the Telegram group. Thank you, ma'am, for your time. Now all the participants can take a lunch break, and we will meet up again for the second session of the day at 1 p.m. Thank you.
Ma'am, thank you very much, ma'am, for your cooperation. મારો અવાજ નતો આવતો ત્યાં આગળ? મારો અવાજ નતો આવતો? મારો અવાજ હું બોલ્યો તે સંભળાતો નહોતો? હું જે બોલ્યો છેલ્લે સંભળાતો નહોતો?
Sir, you are audible. Sir, તમારું mic ચાલુ છે.